All right, college now. Welcome, welcome. Let's do this. This is chapter 4.2, and maybe we'll touch up some of 4.3. So here are my notes from back in the day, and what I'd like you to do is just take a second and copy this down for the first part. So here, let's see. The person is a female. The person is a Republican. The person is a female and a Republican. So the question I ask for you, is it possible for somebody to be a female and for that person to also be a Republican? And yes, this is possible. Okay. Let's look at the next situation. Here, if the person is a Democrat, the person is a Republican, the person is a Democrat and a Republican. Now, is it possible for one person to be both a Democrat and a Republican? And this is where you say, "Keh?" Like, huh? This is not possible. So when we say this situation where it's not possible, we're going to say that this is mutually exclusive, that you can't be a Democrat and a Republican at the same time. Okay? Let's take a look at the next situation here. So here, the idea of mutually exclusive is, this should say two events. So two events are mutually exclusive events if they cannot occur at the same time. So like here, the idea of being a Democrat and a Republican, this is mutually exclusive because you can't be a Democrat and a Republican at the same time. So let's take a look at some examples. Here, if you roll a die and the die, let's say you receive a 4 and a 6. Is this possible? No. When you roll a die, you're going to get a number. You can't get two different numbers at the same time. So this is an idea of mutually exclusive. Something that is not mutually exclusive is taking out a card and receiving a 4 and a heart. Because notice that if you have a deck of cards, you could have a card that is a 4 and it's a heart. Okay? That was a bad example of heart. Maybe that's a little bit better. Okie dokie. So this is not mutually exclusive because this can happen at the same time. All right. Let's take a look at some examples. So this should be attached to the class notes for the lesson. So let's take a look at it. Here, determine which events are mutually exclusive and which are not when a single die is rolled. So what I'd like you to do is, using the definition of mutually exclusive, take a second, pause the video, and try and go through these 4 examples, and let's see what you got. Right? So let's take a look at the first one here. Getting an odd number and getting an even number when you roll a die. This is mutually exclusive because when you roll a number is either even or odd. You can't have a number be both odd and even. Because this cannot happen at the same time, we're going to say that this is mutually exclusive. Let's look at the next one. Getting a 3 and getting an odd number. Now this will not mutually exclusive because if you roll a 3, that 3 is also odd. So you can be 3 and odd at the same time. So this is not mutually exclusive. Let's look at the next one. Getting an odd number and getting a number less than 4. Well, let's see. What are some numbers less than 4 on a die that are also odd? A 1 and a 3. So this is not mutually exclusive because you could roll something less than 4 and it also being odd. Let's look at the next example. Getting a number greater than 4 and getting a number less than 4. Now this is mutually exclusive because a number is either greater than 4 or less than 4. You can't get a number. You can't say x is greater than 4 and x is also less than 4. That's that does not work. Okay. All right. Let's look at the next example, number 2. What I'd like you to do is pause the video and try and do these on your own. A through D. It says determine which events are mutually exclusive and which are not when a single card is drawn from a deck. Getting a 7 let's say you pause the video and you want to see the solutions. Getting a 7 and getting a jack. Notice that if you get a card, that card could be a 7, but it can't be a 7 and the jack. This is this is mutually exclusive, because getting a 7 and a jack, you can't get these two, you can't get them in the same card, on the same card at the same time. Getting a club and getting a king, this will be not mutually exclusive, because if I get a king, that king can also be a club. So I could be a king and a club at the same time. This is possible. What about getting a face card and getting an ace? Just to remember, what are the face cards? If you have a deck of cards, do I have a deck? Oh yeah, here are my deck of cards on me. So where are the face cards? You're either a jack, a queen, or a king, because they have faces. Okay, so notice, can you get a face card and getting an ace? This is not possible. So we're going to say that this is mutually exclusive. Okay, getting a face card and getting a spade, this is not mutually exclusive, because you could get a card that has a face and that's a spade. Where would that card be? Here you go. Here, this has a face and it has a spade. So because it could happen at the same time, it is not mutually exclusive. All right, let's move on. What did I want to show over here? Yeah, okay, let's look at example 3 for a second. And actually, let me show you the notes. So here, let's take a look at this. It says a box contains 3 blue marbles, 4 red marbles, and 5 green marbles. If a person selects a marble at random, find the probability that it is either a red or green marble. So this idea within probability, the basic addition rule that we could follow is if 2 events are mutually exclusive. So let's pause for a second. What does it mean when it's mutually exclusive? It cannot happen at the same time. Okay? Notice that when we take out a marble, when we take out a marble, when it's red, it's just red. You can't say the marble is red and green or red and blue, right? So this event is mutually exclusive, okay? So yeah, when 2 events are mutually exclusive, the probability that A or B will occur is probability of A or B is equal to the probability of A plus the probability of B. So what are we talking about here? And do me a favor, please take a second and copy this down. Here, is this scenario mutually exclusive? Yes, right? So notice here, what is the probability of blue or, I'm sorry, not blue, probability of red or green, okay? Notice by this formula, or this idea here, is let A be the red and let B be the green. So the probability of A or B is equal to the probability of A plus the probability of B. So here we just have the idea that the probability of red plus the probability of green. So here, what is the chance that if I have a box of marbles that I take out a red marble? So notice, how many marbles do we have? We have 3 blue, so 3 blue, 4 red, and 5 green. Okay. So now here, how many red do we have? What's the chance of getting a red? Well, first let's add them all up. So it's 5 plus 4 plus 3. This is 9. This is 12 marbles in total. So notice that you have 4 over 12 plus, how many greens do you have? You have 5 over 12. So this is just equal to 9 over 12, or it's equal to 3/4. And that defines the probability of getting either a red or green if you were to have a box of marbles and you just take one out. Okie dokie. All right. What I'd like you to do is try this question on your own, example 4, pause the video, and yeah, try and do it on your own. Okay, so here, at a political rally, there are 20 Republicans, 13 Democrats, and 6 independents. So if I have 20 Republicans, 13 Democrats, and 6 independents, right? If a person is selected at random, find the probability that he or she is either a Democrat or an independent. So here we have the probability of Democrat or independent. Now we have to ask ourselves this question real quick. Is this scenario where the events are mutually exclusive? Is it possible to be a Democrat and a Republican at the same time? No. So this idea is mutually exclusive, and when we have that mutually exclusive, when it's mutually exclusive, we could use this formula and this idea. So here, the probability of Democrat or independent is just, well, let's see, how many do we have in total? This is 33, 39. So now how many Democrats are there? There are 13 over 39 plus 6 over 39, and that's equal to 19 over 39. And this represents the probability that if you select somebody at random, you have this chance or this odd. Can we reduce this fraction? No, we cannot. Okay, let's try the next example, number 5. It says, a day of the week is selected at random. Find the probability that it is a weekend day. Okay, so probability of weekend. This is actually a pretty bad question. What is this, 2 over 7? Maybe I copied a bad question for you guys, but yeah, my bad. This is not a good question. It has nothing to do, not that it doesn't have anything to do with the lesson, but what is the probability? Find the probability that it is a weekend. Yeah, it's just 2 over 7. Okay, because you have Saturday or Sunday. Oh, okay, I see where this is coming from. So what the setup is, probability of Saturday or Sunday, because these are the only 2 days that are weekends. So you can just say this is 1 over 7 plus 1 over 7, which is 2 over 7. Okay. Yeah, that's probably what the textbook was going for. Okay. Let's go for the next part. Here. Oh, and is this mutually exclusive? Yes, because you can't be a weekday and a weekend. You're either, if you're a day throughout the week, Monday through Sunday, you're either a weekday or a weekend. So this is mutually exclusive. Okay, no more boring stuff. Let's go to a nice question over here. So here, for example 6, it's saying a single card is drawn from a deck. So if we have a deck, let's draw a card. Now it's saying, what is the probability that it is a king or a club? Now let's be careful for a second. Are these events mutually exclusive? Can you be a king and a club at the same time? Yes, you can be. So this is not mutually exclusive, okay? Now, because this event is not mutually exclusive, we are not allowed to use this idea of probability of A or B. What I'd like you to do is, without me actually showing you the formula, I want you to actually think about this. Try and figure it out on your own. Just use your guts. What's the probability that you get a king or a club? And pause the video. So let's take a look here. Imagine if I have all the clubs, right? And let me zoom out a little bit. Oh, sorry. Okay, so let's say if I have all the clubs, right? So ace, 2, 3, 4, 5, 6, 7. I mean, how many clubs are there, right? So probability of clubs is 13 out of 52. Well, what's the probability of getting a king? It's 4 out of 52. So imagine if you thought, oh, let me just add 13 over 52 plus 4 over 52, and I get 17 over 52. And let's see what happens. Let's take out all the clubs. So if I take out all the clubs, they're right here. and if I take out all the kings that are right here, notice that there are 13 clubs here, and there are 4 kings here. But notice how many cards do we have in total? This is 13 and this is 3. So notice that we have 16 cards in total that satisfy this condition of king or club. So we have 16 over 52, but how did we actually get 16 over 52 if we took the 13 over 52 plus the 4 over 52? What is one thing we need to do? We need to subtract 1 over 52, because this 1 over 52 represents how many cards match both a king and a club. How many kings and clubs are there? There is 1 king of clubs. So notice that we have to subtract something that they both shared in common. So here, let's take a look at this formula over here, and let's see what we're talking about. Here, the addition rule number 2, if A and B are not mutually exclusive, so this idea that you could be a king or a club, this is not mutually exclusive because they can happen at the same time. What is the idea? It's probability of A plus probability of B minus probability of A and B. So let's see why this works. Okay. So let me take out a little sticky note over here, and I could write down over here just a little thing to add. So if we have probability of king or clubs, notice this is the probability. So notice same thing. If I have probability of A or B, and A and B are mutually exclusive, where it's not mutually exclusive, this is probability of A plus probability of B minus probability of A and B. So what do we have here? We have probability of kings plus probability of clubs minus probability of king and clubs. Okay? And notice over here, what is the probability of getting a king? It's 4 over 52. What's the probability of a club? It's 13 over 52. But what's the probability of getting a king and a club? It's 1 over 52. So that's where we have that 4 plus 13 is 17, minus 1 is 16 over 52. And 16 over 52, let's reduce that. That's 8 over 26, which is 4 over 13. Okay? Yeah. Hopefully, like this, I remember every time I teach this in person, this one, you need to take time to let it sink in. Okay? Let's try the next one. Here, what I'd like you to do is, okay, this is a little tough one, but what I want you to do is pause the video and try and do this question on your own. It's saying, in a hospital unit, there are 8 nurses and 5 physicians. 7 nurses and 3 physicians are female. And if a staff person is selected, find the probability that the subject is a nurse or a male. And now ask yourself, is this event mutually exclusive? Can you be a nurse and be a male? Yes, you can. So this is not mutually exclusive. Okay? So notice, let's take a look here. How do we, if you want a little hint, how do we set this up? So we want probability of, notice we have probability of we have probability of A or B. And notice that this is not mutually exclusive, right? So we have to use probability of A plus probability of B minus probability of A and B. Okay, so what are we actually taking the probability of? We're taking the probability of nurse or male. So let's say nurse or male. Now we need to find the probability that the person we select is a nurse plus the probability that that person is a male. We need to subtract it by all the male nurses. Nurse and male. Okay? So you need to figure these out. Okay? Let's go with the solution, right? How do we actually figure this out? This always helps, is just to be a little bit organized. So here, let's write staff, and let's write female, male, and total. Okay, so what kind of staff do we have here? We have, you're either a nurse or a physician. Okay. Now, how many female nurses are there? There are 7 female nurses. But notice how many male nurses must there be? There must be 1 male nurse because there are 8 nurses in total. And we know out of those 8 nurses, 7 of them are female. Now, how many physicians are there? There are 5. And how many of those 5 physicians are females? 3 of them. So we know that this is 3 and this is 2. And notice that when we do 7 plus 1, we get the 8. And when we do 3 plus 2, we get the 5. So can we, now that we have this data a little bit more organized, can we answer this question? What's the probability of getting a nurse based on the data above? The probability of nurse is 8 over 13, because how many people are there in total? There are 13 people in total. How many males are there? There are 3 males. So here we should also have a total over here. Notice how many females are there? There are 10. How many males are there? There are 3. So we have 3 over 13. Now, how many of these nurses are also male? It's 1. So we need to do minus 1 over 13. So this becomes 8 plus 3 is 11 minus 1. This is 10 over 13. Okay. Not impossible, but a little tricky. And if you were able to get this, happy face. But happy face in general, right? Good. All right. What I'd like you to do is try this problem on your own. And yeah, trust your guts. Okay. For this question here, it's saying on New Year's Eve, the probability of a person driving while intoxicated is 0.32. The probability of a person having a driving accident is 0.009, and the probability of a person having a driving accident while intoxicated is 0.06. What is the probability of a person driving while intoxicated or having an accident? Okay. A little weird question, but here, let's just be organized. What's the probability of being intoxicated? Notice that this is 0.32. What is the probability of accident? This is 0.09. What is the probability of intoxicated and accident? 0.06, right? You saw how, like, for each part of this sentence, I just broke each thing down. So the probability of a person while driving intoxicated is 0.32. I was able to take this sentence and translate it here mathematically. I could take this sentence over here and translate it mathematically, and the same thing for this third sentence over here. Okay, now let's actually answer the question. It's saying driving while intoxicated or having an accident. So we need probability of intoxicated or accident. So notice this is the setup. We just have probability of, this is your A, this is your B, so it's probability of A plus probability of B minus probability of A or B. So here we're just taking, what's the probability of being intoxicated? It's 0.32 plus 0.09 minus 0.06. And what does this equal to? 0.35. Okie dokie. Okie dokie. Is that it? Oh, okay. Last part of the lesson. And that's it for... Actually... Should I continue? Sure, why not? Here, I don't have the notes for it, but I guess I could just write them down. Here, we're almost done. We're just going to finish up 3 more. So it says, let's look at example 9. It says, actually, no. You know what? I'm going to make a separate video for this. I'll pause right here because I need to get into my notes and be more organized. So, great job, everybody. Hopefully this little short lesson was okay. What I'll do is I'll have some chapter 4.2 homework on the side. What I'd like you to do is try and just answer these 3 questions real quick. Chapter 4.2, if a single card is drawn from a deck, find the probability of selecting the following orders. And for a little extra credit, try and do this one too. Probability of king or club or heart. Okay. This is also a pretty good question, and you can try it out. But try and do this, and I'll make a separate video on going over these 3 questions. All right? I'll see you in the next video.